Hi, today I'm going to demonstrate how to use IP table tracing to trace a firewall problem. For example, I will use nginx-controller installation to demonstrate that how to use IP table tracing. So some of the users, when they install nginx-controller, they will fail at this step, like step 8, checking Kubernetes. And when it tries to install Kubernetes component, it stops here with error. And notice that there is a firewall is active. And it says ensure 6443 are open. And so some of the users that have, they are running Centos or Redhat enterprise. So they have firewall turned on. So I tried to reproduce the problem with firewall running, and I can see I have the same problem. So since we can reproduce this issue, so how we are going to troubleshoot this problem. So the first step is we are going to collect the support package. Okay, so the support package is always important. By the way, this example I'm using nginx-controller, but the problem itself has nothing to do with nginx-controller installation. It could be any users who try to install Kubernetes with kubeadmin, and if they have firewall on, they could have same kind of firewall networking problem. And so in this case, I'm just use nginx-controller as an example. So we got a supported package here under here, right? And so I'm going to unzip the package. So the package, the supported package is unzipped. First, let's look at the logs. So the logs has a failure directory. Let's go to the failure directory. Since the installation failed at installing Kubernetes component, so we might be interested what went wrong with installing Kubernetes component. So under this failure log directory, we have a kubesystem directory and the nginx-controller directory. So the kubesystem is for the Kubernetes namespace that Kubernetes install all the component, the core component in this namespace. So let's look at the kubesystem namespace. So under the kubesystem, kube namespace, we have kubesystem namespace. We have a bunch of directory and files. So there's like a coredns, Kube API server, and Flannel. Yeah, that's all the core system of Kubernetes systems. So we have some output here, pods, and resources, services. So let's look at the pods and see if if the pod is running fine in the Kube system namespace. So let's look at the pods. So this is the pods output here. And we noticed that the coredns pod is in CrashLoopBackOff state. So there's a two coredns pod, and it's both in crash loop, which is not good. And let's notice this pod IP address of the coredns. Okay, so we have issue with coredns, and also under the Kube system directory, we have some coredns directory. Let's look at the coredns directory. For example, this one here. Logs, failure, Kube system, and the coredns pod directory. So it has a description, output file, logs, output file. Let's look at the coredns logs. Let's logs. And so here's something interesting. In the logs, we got a failed error with the dial TCP, this IP, this destination port with no route to host. Okay, so this seems like a problem. And if we Google search this error, like if we Google search this, and there are a lot of similar errors show up in the Google search, right? So let's open the first one. So it's an issue in Minikube. Someone reported a similar error. And if you read it through this ticket, you got a lot of users said their solution is just turn off the firewall or flush the IP table rules, but it didn't explain why and where actually it goes wrong. So, and you could also see some other links. And if you click through all those links, none of them mention about the cause of the actual problem. It's just that, oh, the firewall is blocking some services and just turn off the firewall, which in my opinion is not a very good solution, and it didn't explain the root cause. So we needed to find the root cause here using IP table tracing. Okay, so I already, when I run the installation, I already have my IP table tracing set up. So here's my IP table tracing instruction. So basically just insert a kernel module for netfilter login. and specifically for IPv4 packet login. And here is another command for netfilter log IPv4 packet. And this is the IP table tracing rule I put in the raw table. So why is that? You noticed in the raw table, pre-routing chain and output chain. So why I put the tracing rule here, not other place? So here, if we look at the netfilter packet path diagram that I found from the internet. So here it says when a packet come in to the Linux netfilter system, the first table is going to be the raw table in the pre-routing hook or chain. In the kernel, it's hook. In the user space, it's called the pre-routing chain. So it's chain of rules. So this is the entry point in raw table. So because we want to trace the packet from the start, so that's why I put the tracing rule in the raw table in the pre-routing chain. So this is the input path section. This is a forward path if the packet is not to the local host. And this is output path, that is the packet is sending out of the host. Okay, so that's why I put the rule here at the beginning of the entry point, and then put the tracing rule at the output path in the raw table, right? Okay, so we have the packet IP table tracing set up, and we can now look at the packet. So, but how do we find a packet to trace? Since it's coordinates, first let's find out the coordinates IP address, because the packet is going to coming from the coordinates pod IP, right? To the services, and so let's look at it. So there is a description output for the coordinates, and here we can see it has the IP address 10.244.0.3. Okay, so let's copy this coordinates pod IP, and let's grab this IP in the system log. And so, by the way, the system in our support package, the systemd.txt log file will log all the tracing packet, and it is the same for any Kubernetes installation. Once you turn on the IP table tracing, it can be in the var/var log messaging file, but in our case, it's in this file. And then let's grab this source IP, the coordinates source IP, and then there might be a lot of them. Let's just give one example here. So we have a packet trace log here. Here it says the trace, And here we have the source IP with coredns pod. And here is a destination IP. And we will know what this destination IP is later. But one thing I want to point out is if we want to, because there are going to be a lot of logs in this file, and how do we trace a specific packet? The unique identifier for our packet is packet ID, which is showing here. So this is a packet ID. It's a packet ID in the IP header. So when an IP packet travels through the netfilter system, the layer 3 IP address could change. For example, for DNAT or SNAT, for source address translation or destination address translation. So the IP header IP address could change, or the TCP layer, the source port or destination port could change. But one thing it doesn't change is the IP header packet ID, which is logged here. So if we want to trace a specific packet, when it travels through the netfilter chain, we can just use this as an identifier, okay? So let's copy this packet ID and grab this in the log. Let's output it to a file. Okay, so we got this packet ID. Let's just take a brief look. Okay, so we got another tracing log just for this specific packet when it travels through the netfilter chains. Okay, so let's take a quick look here. So this is the first trace when the packet come in, and since we set the trace rule at the beginning when the packet entered. So this is that's why it's in the raw table pre-routing chain. Again, back to the picture here. In the pre-routing hook or chain, in the raw table, we got the packet, right? So then start from here, it goes through a lot of tables and it chains, right? So this is for this single packet. Now, we got this packet, and so I have an instruction here in my IP table tracing bash script. And we find the packet we want to trace. So we can use this grep to actually make it looks better, looks easier for us to look at. So I put the packet ID here, and also put all the netfilter table here, the raw table, the lat table, the mango table, the filter table, and the final reject. So this final reject keyword is actually coming from the firewalld. So yeah, I forgot to tell you one thing. I also turned on the firewalld log just to log the all the packet that got denied by firewalld. Okay. So, okay. Let's get a root. So this, do I have a root here? Yes. So the firewalld, you got it. By default, it's turned off. So you needed to turn it on, and the log denied all, which means log all the packet that got rejected by firewalld. Okay, so I also have that, and this the firewalld will log this keyword in the log to log all the packet that's got rejected. Yeah, so let's copy paste this grep filter. And we want to look at this packet, right? Yeah, this is one with that as ID. So let's copy paste this egrep filter. So this is just to make it easier to look at the packet trace when it travels through the let filter. Okay, so it is easier for us now to look at with the color highlighted. So first it's got in the raw table in pre-routing. Notice the in interface is CNI0. That's the Kubernetes CNI plugin network interface, network bridge that all the pod packet going to pass through. And this is the coredns source IP. This is the destination IP with destination port 443. We got the error, no route to host, right? No route to host, remember? This guy, no route to host. Okay, so first is raw table, pre-routing, raw table, pre-routing, a user-defined chain, like by the firewalld. And then, so we look at it in the raw table, when the packet travels through, it has the source IP, destination IP, right? So in the raw table, because the raw table is not going to change the IP address, and we should look at the, so this is all raw table. We're going to look at the next is the mango table, right? So here again, raw table pre-routing, mango table pre-routing, right? So we are here now. And then the next is NAT table pre-routing. So mango table is doing the source IP and the destination IP not changed. Still mango table and mango table. Now we come to the NAT table, right? So NAT table is going to do the destination translation in the pre-routing chain. So this is NAT table pre-routing chain. Okay, we think source IP, destination IP, still the same. NAT table, then it's going to pre-routing chain, So some Kubernetes services chain. So where is the IP got changed? Not yet. So in the NAT table, in the pre-routing chain, the source IP address and destination IP address still not changed. That's fine. So we know we are here now, and then we just pass that. So the next is the input chain mango table. Input chain mango table. So here is the mango table in the input chain, right? So okay, here. So here's something we pay attention. In the mango table input chain, the destination address got changed, right? So originally it's this IP address. Now it's changed to this IP address. So what is this IP address? Let's find out. Let's say, so in the support package, let's go to log failure, could be system. Okay, let's just look at the coredns, right? And because I think the port might have something about the IP address. I'll tell you later why. I think we have a note. Okay. Did you notice so the pod is running on a node, and the node has this IP address. That is the IP address. The destination IP got changed to. Okay. I think we have a node something in our package, so it's not here. Is it in? Yeah. So anyway, so one way we can also find it out the IP address is so we are at the destination address IP is changed, right? Changed to this IP address. Let's just group this IP address in the logs. No, that's not a grep here. Let's just group this address in the cookie system. So again, so all the pod, we have a kubernetes pod, we have a Kubernetes proxy pod, all it has this IP address, right? So if you look at this address, just one file. And that's the node IP address. Description. resources, host IP. So there are a lot of ways you can find out this IP address it is. So there is a like Kubernetes system pod YAML, and what's the IP? Do we have a node? Advertise. Anyway, so there is a lot of way you can find out what this IP address is. Basically, it's the Kubernetes controller node IP address, right? So we know what the IP address is. And let's look back our packet tracing here. Input. So that's first one, the mango in the input chain from this destination IP changed to this destination IP. And actually, I missed one thing here. What is this destination IP and a destination port for three? So we actually can find it out from the Kubernetes system. So I have a working installation, and I can list all the services. Actually, the support package also include a services output. Yeah, I'm just doing a lot of stuff in the support package. So, but in your system, you have other means to find out the services, the Kubernetes services, and the IP address information here. Container, Kubernetes system. We have services output YAML file, but is that useful? Is that useful to find what that IP address is? And we will know. So this is all the Kubernetes services in the Kubernetes system. This is a kubedns. So what a cluster IP it has? So it has cluster IP 1096.0.10. That is not the IP address we are looking for. We are looking for this IP address. And so it looks like we can find something. Maybe this, I think this is only show the Kubernetes system namespace. If I go back to a work installation, in Kubernetes, there is also a default namespace. And let's look at it. Default namespace. So did you notice? This is the IP address that coredns is collecting to. And the Kubernetes services name is called Kubernetes. And it got a port 443, right? Okay, so let's describe this services. I think we should add this, add the services in the default namespace into the support package. So we don't have to go spend so much time to trace the packet. So here we have the output. It's Kubernetes services in default namespace. And that's the cluster IP, the port, right? We got a coredns log error, and the targeted port is 6443. And this is the endpoint IP address, and the port. That's our controller, nginx controller node IP. Internal IP, get a node. Okay, so that's the node IP. That's why I know in my troubleshooting, I know that the IP address is the node IP because I have a working installation. So we actually needed to put this information in our support package. Yeah. Anyway, so we know the IP address is a node IP. Let's go back to our packet tracing. So it's okay. We changed it to the node IP with destination port 6443. Oh, that's the API. I forgot to tell you, that's the API. That's the Kubernetes API server cluster services. Okay. So the core DNS is trying to connect to the Kubernetes API server at the cluster IP here and the port here, but the endpoint is we used the node IP and the 6443. So that's why we know it's translated to this IP address in the Mango table in the input chain. Here, from here. Okay, so Mango table input chain, then NAT chain, then filter. So there's another NAT table. We should be able to see it. Mango table filter. Okay, there's no NAT. So it skipped the NAT table. That's fine. And source IP, destination port, filter. So filter probably is going to have a rule to block it, right? Since we have firewalld on. And so a lot of filter chain. And we noticed here, we have a firewalld got final reject. That's a source IP of the core DNS, the destination IP of the node IP, and destination port 6443. That's the Kubernetes API server port, right? So we know the problem is the packet is rejected by the firewalld because the to destination node IP and the destination port API server. So the next step is let's look at our firewalld rule setup. Let me show you the zone setup. So this is firewalld, all the zone and the rule setup. This is a fresh Centos installation, so I didn't do anything with the firewall setting. It's just default. Everything is default. And let's pay attention to the public zone here. So in the public zone, we have the source address translation turned on. That's the masquerade. And we have SSH services turned on, so we can SSH into the node. we have this port open, right? And we have this interface in the public zone. Do we have any other interfaces? So all the other zone in a default Centos installation does not have interfaces associated with it. All the interfaces are empty, right? So why I'm looking at the interfaces? Because the IP address that is configured that is supposed to be configured on the interface, right? If there's no interfaces, we should not look for the IP. So that's why I looked at the public zones that has this network interface. And if we copy paste this interface, show an IP address. With this interface, and pay attention, the node IP is configured on this interface. So we needed to set up a firewall rule in the public zone to allow port 6443. Let's do that and see. Actually, I already have the command. So this is the firewall command to add a port. In the public zone, add a port 6443 TCP allow, permanent, success. And then let's renode. Remember to renode the firewall rule. Renode success, and then let's list the public zone here. So see the port 6443 is allowed in the public zone in the interface, for the interface, okay? And let's rerun the installation. Let's uninstall previous installation so it doesn't mess up. Installation again. Okay. Oh, let's get a local. So we are at step 8 now. Again, checking Kubernetes. Let's see if it works. Yeah, this is taking a little bit long. So just want to show you how I used the Kubernetes tracing. Sorry, I used the IP table tracing to solve the network problem. And so yeah, so this is a useful rules you can use to trace the packet. And if you have other collection issue in Kubernetes, you can use the destination port that you have problem collecting with. And so this is the, you can, once you find the IP packet in the trace log with the unique identifier IP packet ID, and then with some grep counter search to search the packet that passing through all the netfilter tables and chains and firewalld. And we're still in the installation, still at here, warning the firewalld. And let's look at the tracing again. ID 6. Okay. So this is where the firewalld logs the packet got rejected because it is good with destination to this node IP, and the destination port here is the 6443. That's the API, Kubernetes API server. You see, okay, you see here that we are coming to the next stage. Let's agree. So we already passed the step 8, so step 9. So the firewall problem got resolved. And yeah, I think we can end here because here it's going to take a long time. Let's end it here. Yeah, that's all.